preliminary exam, question 10. So if you write on question 10, let's just look what it's all about. Question 10 states a photoelectric cell, so this got to do with a photoelectric effect. A photoelectric cell is connected to a circuit. The lowest frequency of light that will emit electrons from its cesium surface is 5,1 times 10 to the 14 hertz. Violet light of wavelength 400 nanometers is incident on the cesium surface. So 400 nanometers of cesium light shines on the cesium metal surface. Got a variable voltage, microampere, ammeter, voltmeter. Define threshold frequency. Again, your definitions are something that you cannot compromise, so you should learn your definitions. Let's answer the question. Question 10. Threshold frequency, the minimum frequency of light needed to emit electrons from the surface of a matter. The minimum frequency to emit electrons from the surface of a metal. So if you learn your definitions, you got 3 marks. 10.2, let's look at our question. The question says calculate the work function of the cesium metal. Work function cesium metal, he says light will emit the frequency of cesium surface is 5,1 times 10 to the 14. So that's the frequency of the cesium metal. Let's write it down. So we must calculate the work function. Work function equals to HF0, threshold frequency. H is your Planck's constant, which you should know. If you don't know what's H, look at your data sheet. 6,63 times 10 to the minus 34 multiplied by the frequency of our cesium metal, which is 5,1 times 10 to the 14. Right, so I just sure that it is right. 5,1 times 10 to the 14, that is our threshold. So you can work it out. That will give you 6,163 times 10 to the 34 multiplied by 5,1 times 10 to the 14. That will give us 3,38 multiplied by 10 to the power minus 19. And it's your work function, so it is measured in joules. 10.2. That will be 10.2.1. Alright, so that's 10.2.1. So now we must work out 10.2.2. The amount of energy carried by the incident photons of the amount of energy carried by the incident photons of the violet light. So here again we can see it work out at 10.2.1. 2.2. So we can see E is equals to hc over lambda. And if we work that out, our h is Planck's constant 6,63 times 10 to the minus 34. The speed of light will be 3,8, no, 3 times 10 to the power 8. 3 times 10 to the power 8 meters per second. And your lambda will be the lambda of your cesium metal. And we said, how much is that? Violet light, the lambda of your violet light, which is 400 nanometers, right? The amount of energy carried by the amount of energy carried by the incident photons of the violet light. So we need to have the lambda of the violet light, which is 400 nanometers. So we put 400 here. And then if you work that out, take your calculator, 6,638 minus 34, multiply by 3 times 10 to the 8, divided by 400 nanometers. Don't forget, this is a silly mistake. 400 times 10 to the power minus 9. That's where you're going to make stupid errors, like me. Alright, so if you work this out, then you get 4,97 times 10 to the power minus 19 joules. So that's the energy of the violet light that we've got. So we've got the energy of the violet light, and now we must work out 10.2.3. 10.2.3. And the question there will be, now we know the energy of the violet light. It says the maximum kinetic energy of the photoelectrons emitted from the cesium surface when violet light shines on it. So we know the equation is equals to, we know that HF, or we can say the E of the violet light will be the energy of the violet light will be used to eject the electrons on the metal, and then they will be used to, if there's extra energy, they will be used to create kinetic energy, half mv squared. To check that, you can go here. It may be here, or you may have to derive it. Here you can see E is equals to W0 plus E max, right? And your E max is equals to half EK max, which is equals to half mv squared. So I'm using EW0 plus EK max. So then it goes to E is equals to W0 plus half mv squared. So looking at that, the energy of the violet light that we have will be, what are we working out again? Let's just define the kinetic energy. So we're working out kinetic energy, right? So the energy of our violet light is 4,97 times 10 to the minus 19. Right, and that's equals to, and then what's the work function of the metal that we are using? It will be equal to 10.2.1, what it was, 3,38 times 10 to the minus 19. That will be equals to the work function 3,38 times 10 to the minus 19 plus EK, we can say, né? Or we said EK max. Instead of writing half mv squared here, we could have just said the kinetic energy of the electrons that will be emitted. So if you work this out here, we can say 4,97 times 10 to the minus 19, and we can take the 3,38 on the other side, minus 3,38 times 10 to the minus 19, and we can say the kinetic energy of the electrons that will be emitted, the maximum kinetic energy is, if you work it out, you say 1 comma 5 9 times 10 to the power minus 19, and energy is measured in joules, minus 19 joules. 1,59 times 10 to the minus 19 joules. Okay, so that will be how you can work out the energy of the electrons that will be emitted in this question. The maximum kinetic energy of the photoelectrons emitted will be 1,9 is 1,59 times 10 to the minus 19 joules. So that will be the energy that is required. Give one application other than a photoelectric cell which makes use of the particle nature of light. So that was not part of the syllabus. So basically they told us not to give any marks for that question. For that we will conclude our our writing out of the prelim exam of 2022. So hopefully it can help you to see which questions you did well in and which questions you had difficulty. And basically it's a good revision exercise of past exam questions that you can inquire in the future exam. For that, Assalamu alaikum wa rahmatullahi wa barakatuh.